So, good afternoon. Is it afternoon yet? Good morning. Come on. Wake up. I was falling asleep. You're not allowed to fall asleep on me. I'm going to talk about stuff that you couldn't care less about, or you're deeply excited about, or somewhere between those two. So, let's see where it lands. And that's fabs, Internet of Things, and you. While I look after Internet of Things stuff right now, of relevance is my previous time, or previously for Intel, I ran the fab out in Dixie. So I'm going to use that for a manufacturing audience, and I'm going to assume you all are. I'm going to bore you to tears with a conversation about fabs, because I never get the chance to do that. So manufacturing audience, you're going to get some fab stuff. Any of you seen a silicon wafer in the flesh? 12-inch, 300mm thing. So that's what it looks like. On there you can see the individual repeating pattern. That's their individual die or chips. And they're typically a centimeter or so squared, and they're the things that go on your phone or your tablet or your watch or your cloud device or your PC. And I'm going to do a dive into the silicon wafer here to show you what the technology is that we build in this industry in general and build out the road in Dixie. So there's a closer shot of the individual silicon chips. Now I zoom in again. This is like a kind of freeway crossing. So in order to move the signals around, you need multiple layers. There's a lot of flyovers on here. So what you're looking at is, you can see high levels of metal, and then you see lower and lower levels of metal sitting between them. And the stuff between these bits of metal, the insulator is essentially a type of glass, so it's transparent. So I've zoomed in at an angle, and I'm looking at these silicon chips. Now I'm going to swing around at the side and cut through the wafer and show you what that looks like. And this is 1, 2, 3, 4, 5, 6, 7. There's 8 layers of metal on this particular device. You've got 8 freeways crossing one another to carry the signals around. And the lower you get, the smaller the roads are, because it's carrying a lot of small traffic. And up at the top, you're carrying a lot of traffic. There's billions of transistors down at the bottom. There's hundreds of connections to them. So that's what it looks like in cross-section. And I'm going to zoom into the bottom part of this picture. And this is, we call them transistors. This is the switch. This is the actual useful ingredient that allows silicon to do the stuff that it does. So there's 2 of them here, and they switch. Apologies to anyone who's spent 7 years of their life painfully going through device physics. It's either on or it's off. And so it's a switch. And if you have one switch and you can make it work, at very high speeds reliably, with 2 switches you can make an inverter. You can take a 1 and turn it into a 0. With 8 switches you can store a 1 or a 0, so it's like a memory cell. With about 100 million of them, you can make a 32-bit arithmetic logic unit, right? But it's the same fundamental building block. So this is the thing we construct or make with. And I'll zoom in once more. And this is what we call the dielectric. This thing down here are the individual silicon atoms. So these are 3 angstroms apart. You're looking at, with a transmission electron microscope, at the individual silicon atoms connected to one another. And then above it looks a bit mucky, messy, because that's an amorphous material. So that sort of makes sense? We've done a zoom down into the silicon. Now, to give you a little bit of sense of the scale of it, this is a flu virus. And that picture I showed you of the 2 transistors, this is where it would fit with the flu virus. So this stuff fits comfortably in rather small things. Another way of illustrating that is if I take the 300mm wafer that a bunch of you have seen, so 12-inch starting point, if I scale that to the size of the planet, then the individual switches, the individual transistors, scale to the size of your hand. So why am I telling you this? I'm telling you this because this is a taken for granted reality from the last 30 years. It's generally referred to as Moore's Law, and it is a constant doubling, and every 2-year doubling of the amount of these things that you can fit in a piece of silicon. So what used to fit in a large room, and then would fit on a desktop, and then fit in a laptop, and then fit in your phone, fits in a watch, and is now fitting in glasses and contact lenses. And in due course, whether you feel comfortable about this or not, it'll be floating around your injected, embedded in your neural, to support your neural capacity, it'll be floating around your bloodstream. It's just a given. That's the consequence of Moore's Law. And to kind of illustrate the Moore's Law piece a bit, no presentation is right without a few babies' arses being shown. So if you take in the sort of 28 years since the first integrated circuit was manufactured, the first of those transistors on the integrated circuit was manufactured by one of the founders of Intel, Robert Noyce. Since that time, there's been 30 doublings, which doesn't sound that big a deal, right? Intuitively, it doesn't feel like that big a deal. But 30 doublings is 1, 2, 4, 8, 16, 32, 64, 128. Every 2 years, you double all of the history before. It's not an instinctive, easy number to get your head around, but if you look at the consequence of that, if you doubled every 2 years, that 1 kilometer per hour kid crawling away from you, then this year they'd be passing the speed of light. So, okay, fine. I can do some maths. But this is Robert Noyce with the first integrated circuit, and this is a chip we released 2 months ago, and it has 8.3 billion transistors on it. So we've gone from 6 to 8.3 billion in 30 doublings in 28 years. So this is not some fanciful concept. This is a reality. It underpins the information age. That's more transistors on a piece of silicon about a centimeter squared than there are people on the planet, right? Or about 7.3 people on the planet. So, and this happens to be where I work. This is the place down in Leipzig where we manufacture this stuff. Been around for 25 years. So what's my point? So 4 things I want to say to you. My first point in this one is that I think semiconductor manufacturing is pretty cool. And it's cool if you work in it, but it's cool if you don't, because you get the consequence of this, you get the impact of this, which is that 8.3 billion transistors available to you for a couple $100 to do stuff. So you're impacted by it whether you like it or not. And more importantly, I think for an audience like this, in the manufacturing or supply chain type businesses, there's way more consequence of a semiconductor facility than that. And that's what I want to talk to next as well. So what? Why would you care? Other than it makes some stuff. So I'm gonna drag you through my history on in semiconductors. This thing, which gives me the shivers to just look at it, is this Karl Suss. I see a couple of people in the audience who would have been pained with it using the same thing. Was my first introduction to lithography in a lab in Trinity, staring through this thing with my eyeballs twisted, trying to align some masks. So for those of you who haven't done it, don't ever do it. And for those of you who have, I know you will never do it again. But that's what I started on as a piece of lithography equipment. It's a thing, right? It's a thing, and it does stuff. But its intelligence is entirely down to the person who's using it. So there's my thing, my equipment. This is so old that I can only get a low resolution picture of it, but I was overjoyed with the arrival of a thing called the ASML PAS. And this was a cabinet size equivalent of that thing. And it stopped this need for me staring through these pain in the butt lenses to try and get the layers below aligned. It did it itself. So the equipment transitioned from equipment to smart equipment, right? We embedded brains in it and it started doing stuff usefully. So that was a big shift forward. Through the back end of through the 90s in particular, this equipment, lithography equipment in fab, was transformed. This is the kind of thing that's being built now at TwinScan. It was being built through the 90s, and we've extensions of it. The difference here was that this thing was now not only very smart, it's full of sensors and full of intelligence, but we also started connecting it. So to get connected to the people who were using it and to the systems within the factory. So it became a smart, connected thing. And at each of these steps, I think it's fairly obvious that these are dramatic shifts in productivity, right? These are dramatic shifts in how you get stuff and what gets done. So I have to then switch for the next layer up of abstraction, I have to switch to a few pictures, but then equipment management systems came into place. So we could wrap a software stack on the private cloud around this smart connected thing. And you could do things like tell the equipment things or ask the equipment stuff. So the equipment could say, I'm not feeling good, right? I'm in an unhealthy state here. Unfortunately, we do that better with cheap pieces of equipment in a fab, well, relatively cheap pieces of equipment in a fab than we do with people. It's about time we started instrumenting people and working. So our red light can go off saying something ain't right with this guy. You better, do a bit of a maintenance check on him. Equipment's been doing that for a long time. So we have an ability to ask or tell the equipment what to do. We have production recipe management. as SKU counts go up in factories and you're running more and more stuff, how do you make sure the right thing goes to the right equipment at the right time, it's run with the right recipes? You do equipment maintenance, pull the right people at the right time to fix the tool preventively, not reactively when it's fallen over. And then things like paired equipment started to come in, where you'd play with standard deviations. You say, I'm a little bit lower than I plan to be. My next piece of equipment, I'll go to one that's a little bit higher than it's meant to be. So we actually start screwing around with the sigmas on tool process lines. So this is through the 90s as equipment management systems are becoming important. And of course, they end up on all pieces of equipment in a factory. There are thousands of pieces of equipment in a factory. All of these have this capability wrapped around them. And then, of course, the equipment management system gets plugged into the factory management system. We always had a factory management system getting better, but these two things start merging together. So the factory management system then has an equipment management. It's got product management system, doing things like metrology and product demand. As the market changes, you automatically change what you're running through your factory. It does people management systems. When do I need to hire? Who do I need to hire? More importantly, what skills are needed? How do I do online training? And how do you test the online training as they're happening? So you get people management systems. You get material management systems. What are the gases or chemicals that are required to run this equipment or run this factory? How do you make sure that the quality is right and so on? So all these systems start clunking together, and you end up with a factory management system. Does that kind of make sense? You kind of rattled through very tangible things, right up to these fairly abstract concepts, but these layers of abstraction are really important because the thing that frustrates people like me is I keep hearing about Internet of Things and connecting your fridge to your fucking milk bottle. It's just so missing the point. That's not what IoT is about. And for as long as we have this fictitious nonsense going on in our heads, we miss the fact that this thing is tipping in the broad market now, and we're going to see it to California like we always do. If we don't wake up to the fact that we have the opportunity to do it, the difference is in capability, the difference is in mindset. So IoT is not an interesting concept, it's a reality. It's happening now. It's been happening since the Apollo program. It's been happening in big factories, and now with Moore's Law, the price point of that compute connectivity and so on is dropping so fast that all things are getting smart and connected. That sort of makes sense? So I would offer up that Fab is the most impressive Internet of Things venue on the planet. It's just not everyone has $5 billion to spend. So we get into that early on in the cycle because the return on investment is high. But when that becomes $5 million, $5,505, welcome to Moore's Law, then everything gets impacted. So what is IoT? What is the Internet of Things? And my messaging, hopefully, as a manufacturing audience, that kind of manufacturing suite and systems makes sense. Internet of Things is smart connected things in a system of systems. There's nothing new about it. It's been around for decades. It's just hitting huge market space because of the Moore's Law and price points. Does that make sense? So we either sit this one through or we take part in it. If you consider what that looks like outside Fab, so I'll do a couple of sort of supply chainy type stuff. Smart connected vehicles, there's many ways of doing it. If you take something like SAIA, a big trucking company, they weren't going to throw away their trucks to get ones that had intelligence inserted. That would be a pretty dumb consumption of cash. What they do is they bolt in intelligence. So any of you who ever bought, there was a couple of Christmases where everyone was buying a mapping device, right? You plugged into your car, it was the rage, everyone was buying it for everyone, and then that disappeared into the phone. Again, welcome to Moore's Law, gets sucked in, and those devices went away. But we bolted in the intelligence. You didn't throw your car away to have it mapped it. And that's mostly where smart car stuff is happening. It's people bolting in intelligence. And in fact, the most used one is simply sitting on your dashboard and having a device that knows what speed you're at, where you're going, what the traffic's like in this area, recommending what directions you might go, and so on. So you bolt in intelligence. Or you can, increasingly cars are being bought with people considering very heavily what the computing performance, what it's capable of doing, how smart and connected it is. Tesla is a fantastic example of it. It hasn't made it to Ireland yet. They'll be over here soon. They're not the cheapest cars on the planet, but they are very competitive and they're wildly impressive bits of kit. And then some of them, like the Google car at the bottom here, look more like computers with wheels than they do cars with computers. If you look at smart connected road systems, it used to be no lights, and then it's lights on, lights off onto a clock, and then it's lights on, lights off based on sensors saying there's traffic or there isn't, and then it's lights on, lights off based on talking to other traffic lights and understanding the road traffic movement to optimize traffic flow. And then you look ahead for notifications. You're watching this happening, right? This is all things getting smart, things getting connected, and as they connect, useful new business models present themselves. And I should never bring up water to an Irish audience, but anyway, smart connected water. Wouldn't it be good to know? Maybe, maybe not. Don't throw chairs at me. How much water you're using, so that you pay for that, maybe. Or whether there's a leak. So if these systems are happening today, right, they're not theoretical concepts happening today. And if you just put them in a simple Venn diagram model, the vehicle management system is looking at your location, it knows your destination, it knows others in transit, it can optimize energy consumption because it knows the rate at which we don't speed up to the lights to stop and move at the appropriate pace. You can do preventive maintenance on vehicles. So vehicles are getting smart. Road systems are getting smart. Everything from vehicle movement, travel optimization, road works and accidents to redirect around them. And there are some cities that are doing extraordinary work on that. And emergency prioritization. If you're the person who needs the ambulance or the fire brigade, wouldn't it be good if the traffic got out of the way instead of the nonsense we go through now? Easy stuff to do if you've got a smart, connected, intelligent infrastructure. Likewise on water systems. I won't say more about water. But what's more interesting, again, is abstract up another layer. Like I did in Fab, these are things that are becoming smart and connected. And it's hard to get your head around the usefulness of the specific thing. Sometimes it's compelling, sometimes it's not. The thing that's hard about IoT is that that's not what the win is. The win is when lots of things become smart and interconnected, and then they start talking to one another. That's where the breakthroughs happen. And so in this case, a traffic management system might be the vehicle management system, road management system, water management system I just showed you, plus a public transit system. That'd be kind of useful, right, to have an actual functioning traffic management system. And if you chunk the layer up, the traffic management system, the energy management system, safety management systems, education management systems as part of a city management structure, there's no reason not to run a city the same as you run a fab. If we were running a fab without these systems of systems built on smart things, we wouldn't be able to deliver Moore's Law, and it wouldn't be at the price point, so that none of that innovation can happen in an unconnected, unsmart, unconnected environment. So this is going to happen, statement of fact, with or without us. Now, I always have a kind of top 20 of things that are connected. I'm not going to drag you through them, but all I'll say on it is that if you look at the range, there are smart cat doors, there are smart rhino protectors, there are smart rubbish bins, smart baby minders, there are smart watches, smart thermostats, smart wheelchairs, smart kegs. All these things are getting smart. And if you're in the business of making things, and you are not making your thing smart, then you're in the business of going out of business. Because you will be completely disrupted by the folks who make things that are smart. I'm going to say it again because it's that straightforward. If you are a thing maker and you don't make your things smart and connected, you will go out of business because the people who do make them smart and connected will take your business. And the way I'm watching businesses explode and businesses go away day in, day out on the back of that basic reality. Because I'm in Croke Park, Croker are doing some fantastic work here in smart stadium stuff and connected to DCU and Intel and to Arizona State University. We were at an American football game in Arizona State University watching the Fighting Irish play ASU. And at the side of the pitch, the players are out the pitch. And for those of you who see any of it's the same with rugby here, same with any sport, but collision impact is a big deal in the US right now. Lots of people being sued, lots of issues with players that have major problems. It's like boxing, major problems years after they've been involved in the sport. It's a big problem. And so so people have been in that business of helmet making for a long time. And helmet makers are good at plastic stuff and foam and bits of metal. That's their business. They are thing makers. And I sat at the side of the pitch where a thing maker has inserted simple sensors, really simple sensors, looking at acceleration and movement and twist. And that sensor data gets transmitted to the side of the pitch. And now you're watching, their product is no longer protect my head as best you can, really have no idea what consequence it has. Their product is measuring the actual impact. How much twist occurred, what part of the head is impacted, does it or doesn't it have a major consequence? Their insight on their products is exploding exponentially, while other people in that business have no clue what's going on. So they're over-engineering parts of the product that provide better protection. They're removing stuff that never gets used, and they're providing, most importantly, the customer with insight and guidance on what's going on, as well as the medical profession. If you do not make your thing smart and connected, and you're a thing maker, you are going out of business. You're either disrupting or you're being disrupted. And so IoT is at a tip, it's everywhere, and manufacturing and supply chains are good examples. And the money in there is big enough that the return on investment numbers tend to hit early, but it's going to be everywhere, and you disrupt or you get disrupted. Kind of buy that argument? You don't all have to, but please, some of you buy it, because if you don't, it's just, it's like watching Uber consume the Dublin taxi business or the planet's taxi business, because they've taken things called drivers and cars and the people who want to use them, and they've connected them and they process the data, and it's really hard not to use Uber. For those of you who travel, I use Uber everywhere outside of Dublin. It's impossible not to because the service is that good. And they're ripping away those who don't make their things smart and connected. And so my final point, I spend a lot of my life in the Bay Area. It's an extraordinary piece of the planet for a whole pile of reasons, and it's known for the technical innovations, and that's fair. A lot of technical innovations come out of there, and if they don't come out of there, a lot of people stream there, like our very own Colston brothers will go there. What's that about? There's something about that area that makes it compelling from a technical perspective. What we tend to wake up to a little less is that they are business model disruptors, dramatic business model disruptors. So an Uber isn't about new technology. They're just using stuff that's there. It's built on new technology. But the disruption is actually business model disruption. So it's 6 million people. It's a couple of hundred kilometers less. It's 140 kilometers from San Francisco to San Jose. It's a small piece of the planet. It's 0.1% of the Earth's population, and they do just a tad more than 0.1% of the Earth's technical and business innovations. So why not us? We didn't have the opportunity in the microprocessor age because we didn't have access to the technologies and capabilities or an education system that allowed it, frankly. But we today, and same for the PC revolution, and sort of the same for the Internet revolution. Internet of Things revolution, we don't have an excuse. There's nothing you do not have access to. There's little that you don't have access to that you would have access to in the Bay Area. So we don't have the excuse of context and circumstance. And the single biggest thing that stops us from being at the front wave of this in Ireland rather than the front wave out of the Bay Area again is entirely down to mindset. It's stop explaining why we can't do this stuff and start explaining what it takes. That's the difference. It's a mindset thing. And I remember arriving in San Fran for the first time and being like the kind of gay and lesbian community thing was so, leaving green in Dublin all those years back, it was kind of shocking and weird, and I couldn't get my head around it. Well, here we go, a bunch of years later, we're the first country on the planet that, by popular vote, has okayed gay marriage. I mean, how cool is that? What does that have to do with an IoT talk? It's what it reflects. What I didn't know when I got to the Bay Area was that wasn't about gay or lesbian. It was about mindset. It was about openness to new ideas. It was about respect for other people's opinions and a willingness to mash up and go with stuff. And we finally got there. That's the last really significant hurdle for this country. We have 1,200 startups in Dublin alone. We've got $270 billion of foreign direct investment living around the country. We have a tax system that works. We have a country that seems to be able to screw it up in 2008 and get up off our feet and do something about it. There's a lot of stuff we've got going right. The difference between us and California is now really small, and the last residual piece is not looking at stuff like IoT and saying, let me see where it goes or what happens, and what happens to me. It's that enough of us decide to do something about it. So that's my call, is that the next big technical business revolution, why not, from you. Thank you.